Good morning, Amherst. Welcome to the Tuesday, April 14th edition of Corona Groundhog. All right, so from your homework last night, I'm on the gas equilibrium KEQ page. I'm going to turn to problem number 10. So this is a little bit different in that they're giving you a system here, which is the same system as it was in number 9. Whereas in number 9, they asked you to calculate the equilibrium concentrations, and that was part of your homework. And you found, hopefully you found, the equilibrium concentrations, and you found the value of KEQ. So in number 10, they're saying, well, all right, same system, but I've just got a number of moles of each of the reactants and products in a 9-liter flask. Where am I at this point if I just put this mixture in? How does that compare to KEQ? There is not nearly enough room on this worksheet to do this problem. So get yourself some separate paper and your handy dandy calculator, because you're going to need it. So it says calculate the mass action expression. Our system, I'm going to use pencil because it's a lot of algebra. 4NH3, I'll try to write big too. Gas plus 5O2, gas, double arrows, 6H2O, gas, 4NO, come on brain, gas. Alright, so they all work, all the gases work, we can express concentrations like that. So we'll say Q, our mass action expression, is equal to H2O to the 6th, NO to the 4th, over NH3 to the 4th, over O2 to the 5th. So we've got some fairly significant exponents there. And they gave you moles and they give you liters, so you can determine the initial concentrations. So the concentration for NH3, they said, well, you've got 3 moles of NH3. All right, so I've got 3 moles in a 9-liter container. I'm just going to leave that. That's going to be a run-on. That's 0.3 run-on. So I'm going to leave that fraction. That's a 9. All right, and then the concentration for O2 is going to be 2 moles in that 9-liter container. And then the concentration for, what am I looking for? H2O. Is also going to be, let's see, they said H2O, we've got 5 moles of it, so it's 5 over 9. And the concentration for NO. For NO, they said you've got 2, so it's 2 over 9. Try to write hard with this pencil so it comes through, but I'm not doing a very good job. So what I've got are 4 fractions that are going to be raised to some interesting powers. You can say, all right, let me recenter here. Q is going to be H2O. H2O was 5/9. And that is raised to the 6th power. And then I've got NO. NO is 2/9. And that's raised to the 4th power. That whole thing is over NH3, okay, that's 3/9, and that's raised to the 4th power, and then O2, which is 2/9, to the 5th power. Now you could plug this in a lot of different ways, and you could probably do some reductions here, but we have the value of the calculator here, so it's just a matter of plugging this stuff in. Try and get this so they're both in the screen. Alright, so I'm going to go parentheses, I don't need the zeros, right? 5 divided by 9, close parentheses. Let's raise that to the 6th power. I'm going to hit enter. Times parentheses 2 divided by 9, close parentheses. I'm going to raise that to the 4th power. I'm going to hit enter. Divided by parentheses 3 divided by 9, close parentheses. Let's raise that to the 4th power. Enter. Divided by parentheses 2 divided by 9, close parentheses. Let's raise that to the 5th power. Enter. So that's 10.7167 yada yada yada. I want 2 sig figs. It's roughly equal to 11. Okay, well, our previous problem said KEQ was 0.088. Now, that's a lot bigger than that. You've got a lot more product. When you're done, KEQ says, well, I have a number less than 1. I want more reactant than product. And Q says, I've got 11. I've got a lot more product than reactant. This system is going to go back toward the reactant side. So, is the system at equilibrium? Absolutely not. If they were equal, it would be at equilibrium. The value is too big. It has too much product, and it will proceed back toward the reactants. Part of your homework tonight, we're going to do number 11. Same kind of deal. They give you a value for KEQ, you're going to solve it for Q, and you're going to do that comparison. All right. Let's take a look at the next page. Once again, there's not enough space to write. We'll do one, you'll have the other one for homework. So here's H2, Br2, 2HBr. They give you a value of KEQ, pretty big value, 64. They give you a mixture of 2 moles of H2, 2 moles of Br2 in a 10-liter vessel. Calculate the equilibrium concentrations for each of these 3 gases. Seems like the problems we've done before, but it's a little bit short. I'll show you what I mean. H2 gas plus Br2 gas, double arrows, 2HBr gas, and they give you KEQ of 64. Players in the game, H2, Br2, HBr, initial change, equilibrium concentration, moles per liter. Okay, they put in 2 moles of H2. They put in 2 moles of Br2. You start with no product. Whatever changes are here, these are losses, these are gains. And you've got a 10-liter flask. Looks pretty familiar, except in the previous problems they said the change was something, or the equilibrium concentration was something, and I'm missing that key piece of information here. So what are you supposed to do in a situation like this? Well, in math class, you might have heard of let X problems. If you let X be the loss of one of your reactants, stoichiometrically you can come up with the X's for the other losses or gains for products. So I'm going to say let X equal the amount of H2 I'm going to lose. Okay, so when I'm done, this is going to be 2 minus X. Stoichiometrically, it's 1 to 1 with hydrogen and bromine, so this is also going to be X. And this is 2 minus X. And stoichiometrically, if this is X and that's X, then this is 2X. It's a coefficient of 2. So this is going to be 2x. Alright, well, I have algebraic representations for the equilibrium concentrations, and I could say KEQ is equal to HBr squared over H2 times Br2. Okay. Well, HBr was 2x over 10, and I'm going to square that. H2 was 2 minus x over 10. I don't know why I'm adding that 0 there. And Br2 was also 2 minus x over 10. So I could say that's equal to 2x over 10 squared over 2 minus x over 10 squared. And they also said KEQ is 64. Okay, well, let's take the square root of both sides of that. Square root of 64 is 8. So that's 2x over 10 over 2 minus x over 10. Let's set that over 1. Cross multiply. Let's that page here. 2x over 10 is equal to 8 times 2 minus x over 10. I'm going to distribute. Two x over 10 is equal to 16 minus 8x over 10. Those 10s would cancel out. Two x equals 16 minus 8x. Add 8x to both sides. 10x is equal to 16. Divide by 10. X is 1.6. So there's a lot of algebra to solve it for this mythical x, but x takes me back to here. So H2 is equal to 2.0 minus 1.6 over 10, which is 0.4 over 10, which is 0.04. That's one of your equilibrium concentrations. Br2 is also equal to 2.0 minus 1.6 over 10, which is 0.4 over 10, which is 0.04. And HBr is equal to 2 times 1.6 over 10, which is 3.2 over 10, which is 0.32. Okay, so your homework will include number 13. So you have two homework problems today. You got number 11 and number 13. Take care.